Hello, welcome to Berkshire Guitar Amplifier Repairs with me, Stuart Smith. On the bench today, a Marshall JCM2000 TSL triple super lead. This will either be quite a quick video or it will be a bit of a nightmare. This amp is blowing HT fuses. Now, I've seen this amp before about, I don't know, a year or two ago, and at that point I changed the main printed circuit board on it, because these boards, or I should say some of the issues of these boards, the HT leaks actually through the board to places where it shouldn't get to. The board is very slightly conductive. I've had to replace dozens of these boards, and Marshall no doubt have issued thousands, if not tens of thousands of them. So I don't think it's going to be that problem, because it's got a brand new board in. So let's whip the chassis out and see if we can get a handle on what's up with this amp. Here we are, top side of the amp, and it all looks kind of reasonably good. I can't see anything obvious with the power valves, for example. This is interesting though, I don't remember this before. All this deposit here, it's a kind of a white powder. That almost certainly, I would have noticed that last time I had the amp. And it's all seeping out under here. And along here, I've no idea what the implications of this are. And all the way along here, is it just simply corrosion? Aluminium corrosion? I don't know. It turns into a white powder. Could be something's been spilled down here through the top, like a can of Coke or something, or beer or whatever. Certainly not good, but I don't know whether it's relevant or not. Well, let's turn it upside down and have a look on the underside. Well, not a huge amount to see here. I can actually see this, all this gunk here that's come through, and you can see it along that edge there. Look, hasn't seemed to have gone to the board. As usual, I don't like these TSL or DSL amps, I have to say, really because of reliability issues. Just look at the sheer number of interboard connectors there are here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 33, 34, 34 that I've counted, all of which have got 3, 4, 5 pins on them. So 34 times 3, 120, 150 connections there, any one of which goes wrong and the amp doesn't work. So in my humble opinion, this is very poor design. I would never design something with such inherent reliability problems. But anyway, that's an aside. And the main board is this one at the bottom here, so I've changed that. And to do that, of course, you have to completely strip the entire amp down, including taking all these connectors off. It's quite a big job. There should be an issue number on the board. I don't know if I can see it. Yes, it's issue 20. So this is a very late board, in other words, a very modern board, and it will not suffer from that hygroscopic problem which the earlier boards, issues 3, 4, 5, 6, that sort of thing, suffered from. So if you've got one of these and you're blowing HT fuses and you've got an early edition board, the edition number is down under there where I'm pointing. If it's a 4 or 5 or 3 or 6 or something, then that's likely to be the problem. If you've got a higher number, I don't know what, to be honest with you, above 15 or something certainly, then that's not the problem. Right, now what I'm going to do now is I've taken the power valves out. I'm going to replace the HT fuse and plug it in again, because this will tell us a lot. If the HT fuse blows immediately, then it's nothing to do with the power valves. They're not even on. They haven't even had a chance to warm up. So let's see if this is a problem of HT fuse blowing instantly, or whether it's some sort of problem when the valves get hot. Okay, I've put a new HT fuse in, a T1 amp fuse, and I will now plug the amp into the mains and we'll turn it on. That's come on. Another thing which causes HT fuses to blow is short circuit HT caps. Here are the HT caps on this amp, but I would be very surprised if any of those are faulty because it's a brand new board. Possible, I suppose, but let's hope not, because we're in for a major strip down job if it is. Right, so the amp's on, power valves are out, so let's just turn on and see if the HT fuse blows. I have no idea if it blew or not, so we'll turn the amp off and have a little look. Okay, it hasn't blown, which I'm sort of pleased about, really. I prefer HT fuses to blow when the valves are in, so we could just have a faulty valve. Right, so the HT fuse is good. Right, well, what do we do next? We could put in two valves and see if it blows, I suppose, or one valve. Start putting in power valves one by one until it blows. Could have a faulty valve here. I could put the valves, all four valves, up on the tester and see if one's faulty. Not quite sure what the easiest, simplest thing to do, really. That's what I feel like, to be honest with you. Let's pop a couple of valves in and see if it blows the HT fuse. It's quite bad, the corrosion around here, look. But it hasn't gone onto the pins or anything, so I don't think it's anything like this causing a short or anything like that. I don't think that's the problem. The pins are all nice and clean. Anyway, let's leave that one alone for the moment and pop in these two. I suppose we could do one at a time, couldn't we? Why not? Right, turn it on. And HT. Quick look at the fuse. We can probably tell this just by inspection. It's quite obviously when it's blown. That's okay, so the fuse is still okay. As I say, I did turn this on. I put a new fuse in and turned it on as soon as the customer bought it to me, and it blew the fuse instantly. Well, it blew the fuse. I can't remember if it did it instantly or not. Right, so I've got two valves in now. So same thing. Let's leave it on for a minute or so as well. Let those valves warm up. Okay, the amp's been on for about 10 minutes with two valves in, and I thought I'd just plug a guitar in and a speaker, and it does actually work. Bit distorted. Quite sure if that's right or not, but anyway, it's working. A little bit hissy. I can hear quite a few kind of hissy sounds coming from it, which you won't be able to hear. Right, well, not blowing fuses at the moment, but we only have two valves in, so could it be something wrong with one of these two remaining valves? Well, there's only one way to find out. Okay, there's three valves in. The only one we haven't put in is this one around this corroded base here. That's working still. Worst case scenario here is, of course, that it doesn't blow fuses now, and we're back with some sort of horrible intermittent fault. Of course, I haven't checked the BIOS on any of these yet, so I've no idea what they're doing. But anyway, we only have one thing to do. Let's pop this last valve in and see if that blows the fuse. Here we go, 3, 2, 1. No. Typical, worst case scenario that. Definitely blew the HT fuse when I tried it when the customer bought it, and now of course it's not blowing the HT fuse. Very irritating. Sounds okay, that. Cool, these valve bases need cleaning. Terrible. I'll do that, that's nothing to do with any problems. Yeah, they're better already just for a wiggle around. Okay, I think the only thing we do now is to get a bias probe on one of these valves and see what sort of current we're pulling. You know, if it's pulling quite a lot of current, then that might indicate that you know, that could cause the HT fuse to blow the combined current of all four. So let's do that as a next step. So let's turn on the amp on this left hand valve here. Not sure if I caught it on video, but this one didn't have any current. This is weird. Not sure what's going on here. We're not getting any plate current on these valves. I can hear the amps working okay. Okay. Okay, let me kind of show you where I've got to. I've got one valve in at the moment, and it's giving on my other bias meter 34 milliamps. I can also measure that on these pins here, and it should be 0.3 volts, which it is. Look, 0.035. Sorry, 35 millivolts there. Look, because it's across a 1 ohm resistor, so that's all right. And on the other side, as you'd expect, we've got nothing because there are no valves plugged in. So if I plug another valve in here, I should get double that. I should get, you know, 70 milliamps or something. So let's plug that in there and see what we get here. And it's warming up. Look, 40, 50, and that will eventually creep up to something sensible. So those two valves are working okay with sensible currents, and on this side we have nothing. That's because of course we have no valves plugged in. However, when I plug a valve in there, I get runaway current. So there we go, we go into there now. We will go on the side here. Nothing at the moment. Look, it's warming up. 0.6, 0.13, that's 3700 milliamps to 300 milliamps. I'm turning that off immediately. This is running away current wise. So let's just check that that's the same for the other socket. In other words, is it this pair that's being affected, or is it just one valve? So once again we'll turn on. think at the moment it's warming up, 0.1, 0.4, yeah, it's running away, look, several hundred milliamps there. That's why the fuses are blowing. So this side here, these two valves here are suffering from runaway bias. In other words, they are not biasing up to anything like a sensible current, so we need to investigate why that is. Okay, this resistor here, R6, is open circuit. It should be 1 ohm. That one there should be 1 ohm at a couple of watts, and that's open circuit. So that's in the cathode of the two valves, of that valve pair. So those valves were not conducting at all. I'm not quite sure why I was getting those readings. Might be something to do with the way the bias current's brought out on this amp, but anyway, that's why one pair isn't working, so that needs replacing. In order to get to that resistor, I'm going to have to take this board out. It's not actually as difficult as it looks. You just have to undo those two screws there and take all these nuts off, and the board will just come out and allow us access to that resistor. But thinking aloud, I'm kind of wondering what's gone on here. When those 1 ohm cathode resistors go open circuit, it just means they've taken too much current. Too much current has flown through the valve pair, through that resistor down to ground, and it's overheated. But what's caused that is of course always the question. And by the way, that would have taken out the HT fuse, too much current flowing through the valve. But what has actually caused that to pull all that current? All we can really do is replace it and then bring the amp up and see if the current through that pair is looking sensible, and if it isn't, of course, turn off straight away and investigate that a bit further. But anyway, let's get this board out, which won't take too long. There we go, that board's swung out of the way, and we can now see the resistor. You can actually see where it's got hot there, look. So we'll just change that, and then we'll pop the board back in with just a couple of retaining screws and see what the bias is doing on that side of the amp. Okay, the resistor's back in, the board is temporarily back in. This is the good side, this is the bad side. We're just going to double check everything's okay. So I'll turn on, and we're getting 70 milliamps, which is 35 milliamps per valve, and that's perfectly okay. So we're going to swap this now to the other side. Obviously we're going to get nothing, and we're going to pop a valve in and get ready to turn off straight away. Let's see what happens here. Nothing yet, but the valve's cold, so that's okay. Ideally we want to see this coming up to 35 milliamps. Nothing. Oh, there we go. Right, that's coming up. It's looking promising. Okay, well that's looking good. Alright. Let's turn it off and put the other valve in. It'll stay at a lowish reading for the moment until the second valve kicks in, and it should start coming up again as this one warms up. Going to go into that range actually. 30 milliamps. That's that valve warming up now, look, you can see quite nicely. Forget the negative, it's just I've got the probes the wrong way around. And that's all looking pretty good. Obviously we haven't biased it, it's lower than the other side, which is running at about, that's about 53 at the moment, and the other side is running at 60. We want about 35 milliamps per side, so we may as well just bias it whilst we're here. And just to reiterate what I said, I'm concerned about why that runaway bias happened. You know, in other words, why did we have so much current going through these valves that it took the HT fuse out and took out the 1 ohm resistor in the tail of those two valves. It's not super critical, this. Yes, 3 or 4 milliamps either side makes no difference to anything, but that's perfect. It's about 35, 36 milliamps per side. Okay, so the amp's working. So that's working okay. Bit hissy, but I'll have a look later on to see if one of these preamp valves is a bit hissy. Not worried about that. I'm more concerned about why this, why this happened. This definitely was not like this before. I wouldn't have left it like that when I changed the valve. I would have just, at the very least, scraped off some of this crud here, and which is what I'm doing now, and tidied it up a little bit. Definitely not my style to leave this. So did something get poured down the amp, and that caused runaway bias and took out that 1 ohm resistor? Why? But that doesn't make sense, because why did it blow an HT fuse when I tried it first, when the customer bought it to me? That was 2 days ago. First thing I did was pop in a new HT fuse, turn it on, bang, the HT fuse went. Well, that makes no sense if some time ago some coke was spilled down here, because it'd be blowing HT fuses now. Annoying. I don't like mysteries, because mysteries come back to haunt you, and he takes the amp away and it starts blowing fuses again. Well, it's getting on a bit now here. I'm going to call it a day on this amp for tonight, and we will turn it on again in the morning. This is perfectly stable. Look, 73, 74 milliamps each side. That's perfect, really. Take that off. That reminded me. I'll leave that on. That reminds me that was the pair that was problematic. There's something that's gone on here to cause a huge amount of bias current to flow through these two valves, enough to take out the 1 ohm tail resistor and to blow the HT fuse. Nothing we can do really apart from monitor it. So that's what I'll do. I'll let you know how I get on. See you in the morning. Nighty night. I lied just then. I haven't gone to bed. I just thought I'd track down this noisy valve, and I pulled out V1. There's a lot of hiss which you wouldn't be able to hear, sort of noise. Pull V1, hiss doesn't change. Pull V2, hiss vanishes. This is a good way, by the way, of diagnosing the faulty valve. And I popped in a Sovtech, and the hiss has gone away, so that's actually nice and quiet now. However, it's quite microphonic, this valve. Listen. Compared to that one, that's a little bit. That's a little bit. That's a little bit. That is very. So I'm just interested to see what happens if I swap that for a JJ. Valves do vary in their microphony. Just let it warm up. Very quiet. Oh yeah, that's working. So maybe, and that V1's alright now, so maybe it wasn't, maybe it was tapping on that was transferring through to this one. And that's, look how quiet that is. Look at the comparison between that JJ there. Someone will be wincing at me changing valves live. I do it all the time, don't worry. Listen to that. Yes, tapping on any of these now produces that microfilament. It's actually this which is the problem. Interesting. Change that one for a JJ. And gone, look. Microphony gone. Well, that's interesting. I thought one of these power valves was microphonic too, but it was literally being transmitted from there all the way back to here. That's gone too. Yeah, that's quite bad, that valve. I don't think I can actually keep that. Brand new valve, that. Brand new Sovtech. Huh. Annoying. So that's solved the problem with the noise. The hiss has completely gone. And obviously we've got no microphony now, and we are still good with our 75 milliamps or whatever. And over here, the other side, still the same. So that's good. Now I am going to turn off now and head for bed. So I wish you a good night yet again. And see you au matin, which is Portuguese, Spanish or German, I'm never quite sure which, for in the morning. No, I'm joking with you. Okay, here we are again after a bit of shut-eye, and I've turned the amp on this morning and it's exactly the same as last night. So we have 37 milliamps on one side. So where are we with this? Well, the thing is, for some reason this pair of valves here at some point took too much current. So much so that it took out the 1 ohm resistor in the cathode of this pair and blew the HT fuse. Now I said a couple of times on the video that I replaced the HT fuse and it blew as well. Actually that's not true. I looked up my notes on this. It was a few days ago that the amp came in, and my note says HT fuse blown. And that means that I took out the HT fuse, had a look at it, and it was blown, and I put it back in again. So I had misremembered that I had changed the HT fuse. I hadn't, which is sort of good news in a way, because if I'd seen it blow and yet the amp is all seems to be good, then I would be a little bit worried. But it seems like it blew for the customer at some point, and we don't really know why. I'm not sure it's related to this gunk here. I tend to think not. I did ask him about that, and he has no memory of this ever having had anything poured in it or suffering any kind of accident. So we don't know what's gone on there. So all I'm going to do now is leave this on for an hour, and this out. So anyway, let's have another look. So we've got 74 milliamps on one pair here, which is 37 milliamps per valve, and on this side we've got 71 or something, so they're not far off. I could tweak this up a little bit. As I often say, a couple of milliamps makes no difference whatsoever, so there we go. So 75 on that side. Don't forget this is measuring the it's actually measuring the voltage across a 1 ohm resistor, and the 1 ohm resistor is in the cathode of a pair of valves, so we're measuring twice the current, if you know what I mean. So 35 milliamps through this, 35 milliamps through this will give 70 milliamps on here. 70 millivolts actually, 73 millivolts, so millivolts across a 1 ohm resistor turns into milliamps of current by Ohm's law. So there we go, that's nice and stable. Can't see anything wrong with this at the moment, and we'll just leave that on now for an hour just to make sure it doesn't kind of run away and blow the HT fuse, and that's all I can do really. Okay, 2 hours in and no change whatsoever, so still pulling 36 milliamps on that tube and 74 on that pair. And what have we got on this pair? 74. Amazingly well balanced. So I can't really do much more here. I'm going to call that a wrap and put the amp back together. And you know, a bit of a mystery really about why that failed. I just have to hope it doesn't fail again. But not a lot more I can do. So I'll get it back together and wrap up the video. Okay, well there you go. A little bit unsatisfying, that one, in that I don't really know why that HT fuse blew, and of course that means it could go again at some point. Nothing much more we can do. I've given it a good old look over and we've soak tested it for a couple of hours, so I think it's back to the customer now, and it may or may not come back to me at some point in the future. Anyway, I hope you enjoyed watching it. Maybe not my finest and most interesting video, but I hope you always learn something from the videos. And I'll catch you again on the next video. Thanks for watching.